Good? Yeah? Okay. Perfect. So thank you to be there for this last NI week session. Almost done. 1 hour left, and then everyone will be okay. So the title of this session is using PPL to build and deploy large scalable application, and we will talk about also what NXG will do for us with PPLs and compiled code in the future and already. And in the title, I put large, scalable of course, but large application because PPL will benefit to you more if you are developing large applications. It benefits to everyone, it can benefit to everyone, but especially you will see more benefits if you are dealing with large applications. So who is using PPLs already in a regular flow? Who tried maybe to use PPL, but it was too much pain? They just abandoned.
Oh yeah, me too. It was painful, but I got through it.
Yeah.
Okay. All right. So maybe I define what is a large application, and it might be different for everyone. So an application between 0 and 1,000 VIs, maybe 30 libraries. And when I say a VI, it's a VI in one screen. Okay, it's not a.
It's not the.
Yeah, exactly. So this is not really a large application, and PPL will not really benefit a lot in that situation. I'll say between 1,000 VI and 5,000 VIs, 30 to 200 libraries, that's a large application, and other than that, it's a very large application. That's my sense. So you have the link for the presentation content, so you will be able to download the slides as well as some benchmarking code. So I will show you some benchmarking with PPLs, and if you want to reuse that code and maybe benchmark your own applications, it's just scripting, so you can look how I've done that and tweak it and reuse it. Neither is of StudioBots. So StudioBots, it's an alliance partner company based in Quebec City. We have operations in the US, in Europe. We do mostly services, LabVIEW development, LabVIEW consulting. Our main area of expertise is deploying LabVIEW application, deploying software, deploying code remotely. And we do also training. And we are DQMH trusted advisor, so we know DQMH and we can help you with DQMH.
Oh, you have certifications for DQMH.
We have 2 products on the LabVIEW Tools network. VLT, it's our main product. It's been there since 2012. You can use it for free up to 5 deployments, and you're paid. But you can use it for free with no time limitation. And there is another cool tool to automatically generate LabVIEW controls, custom controls from pictures. And it does the recoloration of your pictures directly in the application. So let's start with a real customer request who is asking us to create an automated test system for LNB, which is the thing at the end of the arrow. We are asked to develop 2 tests, phase noise test, oscillation test, and log the results to the database and generate some reports. So very classic application that probably most of you have worked with. So we do our homework and we define, how we are going to componentize our application and decouple our application. So we have a main application. Okay, they want us to do tests. We will need to hardware inputs and hardware outputs. So we create components for hardware inputs, hardware outputs. We want to do logging, component for logging. We want to do report. Raise your hand if you find this is a good decomposition of the application. You.
I'm just asleep.
Okay, it's not decoupling. There is no decoupling, and it's not cohesive. Okay, there is no reason to group all the hardware inputs in a component. It's not what we want to do. We want functional decoupled components. So I'll explain a little bit more what is coupling and cohesion. High coupling means that if you change something in one of your components, in one of your modules, it will impact many of your other modules, and we will have to rewrite code in a lot of modules. The opposite, if you have a low coupling in your application, when you make a change in one of your modules, it has a minimal impact on the other modules, so it's more reusable. And In order to decouple your modules, you have to think of them as really independent software components. Like forget about the entire application. Think about your module as independent program almost. And to help you to do that, you should, you know, leverage design patterns, framework, actor framework, maybe DQMH, state machines, create abstraction layers. That will help you to decouple your code. And I mean, also to decouple your code, you need to write cohesive code. High coupling is not good. Cohesion, the code is cohesive if the functionalities in your module have a lot in common. And you can describe the responsibility of your module in a single, simple sentence. No and, no or. Don't use unrelated dependencies in your module. It's not because you want to log, if you want to log your hardware measurements, you don't have to make a dependency between your logging module and your hardware module. You know, it's using unrelated dependencies. So low cohesion, it's not good because components are not sure what they do. And high cohesion means they have a very well-defined responsibility.
Do you consider OO composition to be coupling?
OO composition to be coupling?
Like class.
What is OO composition?
Well, in your classes, if they contain other classes, you know, they're composed of other classes.
Yeah, that's,
If they have a lot in common,
yeah. If
they
they do
can
the
be.
same thing, they're good.
Definitely it happens that you can have a component with multiple classes and they take care of the same responsibility, so that would be fine.
Yeah, what it's bad is when you are putting the kitchen sink and the apple tree in the same basket. They're not related at all. You can put them.
I'm thinking low-level functional classes that are shared a lot.
Yeah, but make sure you decouple them through
Exactly.
interfaces.
Yeah.
No static coupling.
Exactly. So the recipe of success, low complete modules, high cohesive code, and you have something that you can reuse, scalable, you're gonna be successful. Okay? I'll not show you the opposite way, so it could be bloody. High complete modules, low cohesive code, not reusable, not scalable, you're gonna fail. So let's do our homework again, and we now decouple our application. We have the main application, the UI, and we have a module that is a test sequencer. It will be able to run multiple kind of tests, whatever the test it is. We have phase noise tests, one module, oscillation test, one module, and they call each one the module that is responsible of a particular instrument. The logger is one module, etc., etc. And you can see pretty much that almost each of these modules can be reused in another application. If you have another application where you need to have a XML file config, you take your XML file config module and you can reuse it as is. Okay? You need to communicate with your signal analyzer in another application. You take your module and it can be reused as is as well. So sometimes there is some modifications to do, but at least it's a lot more easy. So we implement that in LabVIEW. This is our project, and we create folders with all your code, etc. One folder per component. Do you think it's enough? You like that? You do that? No. Okay. You should group your components not into folders, but into libraries. And why using libraries? Libraries, it's a way to organize your source code so it can be independently so it developed, and you can define a responsible for that library, and he will take care of developing this library, maintain this library. You can test a particular library independently. You can reuse, of course, and share that library. There are all other advantages of using libraries. You namespace your VIs, so you will avoid name conflicts. It might happen multiple times that you need to open a connection to something like that. So you can easily have name conflicts. So libraries avoid that. they share a common icon header, so when you look at your code, it's mentally easier to find out which component is part of this code. And also it enables discoverability. If you drag a VI in your project, it's going to bring up the entire library, so you see all your component, all the API available in your module, in your component.
So, Matthias, just for Grisilino here, classes are a type of library, so this is the same thing, yeah. Okay. Go ahead.
Library provides access scope. So let's look at the file config libraries. You can define a private access scope. There are other access scope, public, community, private. This way you prevent basically the use of these private VIs outside of the library. So you make sure it stays private, and only the public API is used by the other components. So it really helps decoupling your code. So we talked about library. Who is not using library today?
You mean like classes and variables?
No, like just, grouping VIs in folders and not especially grouping
So
them.
one mother folder.
Yeah.
Yes. Mother. Mother.
Well, I hate to say it, but as a consultant, I see a lot of that code.
Yes. Yeah, and we see a lot of local variables and stack sequence structure and all that. So let's compare now the library and packet project library, and the topic of today is packet project library. So LabVIEW library, the extension is LabVIEW. It's multiple files on disk, okay? When you have a library, it's the LabVIEW file, which is an XML file that is pretty much kind of a directory of the files contained in your library, and all the VIs. And usually you put them in a folder. Okay? It's easier to reuse and share. You grab that folder, you give it to someone else, and it has the entire library. This is source code, so it can be edited and it can be portable across targets and operating system. The packed project library, you add a P to the extension, like packed project library. It's one file on disk. It's compiled code, you cannot change it, it's immutable. And so you must rebuild it for each target with a different operating system. Yes.
And I assume also per version of Lab, correct?
Yep.
Yes.
No, not starting at 2017.
Nothing.
I talked about that. Yeah, Fabiola has a good point. Starting with LabVIEW 2017, there is backward compatibility for packed project libraries. So you don't have to, if you build a packed project library in LabVIEW 2017, you can reuse it, you can consume it in LabVIEW 2018 and further versions. You cannot consume a 2018 PPL in LabVIEW 2017. So the next slides, I show a lot of benefits of PPLs, but don't worry, there is also a lot of caveats, okay? I'll talk about the caveats at the end, so I'm not going back and forth, so yeah, just don't think that it's just all benefits. There are some pain points that come with PPL, and they will come later. So one of the big advantages of the PPL I see is reducing the time to load your application. Because the LabVIEW library, the LabVIEW must be recompiled before use, and the PPL is already compiled, so you save the time of the compiler. It makes a huge difference if you build your libraries into PPLs, especially if you have large projects with large number of libraries. So I did some benchmarking. I have a main VI that is calling from 1 to 20 libraries. There is 50 VIs in each library, so 20 libraries is 1,000 VIs. And the main VI is calling all the VIs in all libraries, okay, for the benchmarking. And you can see that with just 20 libraries, it's 65 times faster, the same code, if you compile your LabVIEW into PPLs. So I have some customers, when I load the project, the main VI, I have to charge 1 or 2 hours before I can start coding. Just because I need to open the code, because it's all source libraries. This one surprised me a little bit. The time to load the project is actually longer if you rely on PPLs than libraries. But it's just 2 times, faster to load with libraries. So it's not like the 65 times. It's not a big deal. And I brainstormed a little bit about that, and I think it has to do that basically a PPL it's a one file, so it's a larger file to load. When you load a library, you can basically just parse the XML and you have the content of your library. When you load your project, probably you need kind of load the entire file.
Did you benchmark between debugging enabled and disabled?
No, it's all debugging disabled. The benchmarking.
Okay.
Because if you build your PPL with debugging enabled, it basically keeps the source code. So it was not the purpose of that benchmark. It was other questions. So it's not that much pain. It's just 2 times faster, and it makes sense. You load an entire file that is larger and contains all the code instead of just loading the directory of your library. The big advantage of using PPL is not only the time to load, but the time to build. Okay, when you build an exe that calls LabVIEW, LabVIEW resaves all the file in libraries and maybe do some recompilation. If you build an exe that calls PPLs, LabVIEW just take the PPL and copies in. It's a simple file copy on disk. Again, it can make a huge difference if you have large applications when you need to rebuild your main application. Okay, so some benchmarking again. Same libraries, same number of libraries, 1 to 20, and we went to 12 times faster to build the application that calls PPLs versus the application that calls the same libraries source.
Yeah, but at least it's linear, right?
Yes.
They don't get worse.
Yes. So the application that use LabVIEW, if you build this application into an executable, you get one executable that is probably for this size of application around 40 megabytes. If you build the same application into PPLs, you just have basically your main VI. It's simplified here, but you just have the main VI in your exe, and then each PPL is its own product. So when you double click on your application to open the application, you just have 4 megs to load in the memory. So your application shows up immediately. You immediately have the icon, and then you can start maybe to have a progress bar while you load your other modules and PPLs. Chris.
So I'm going to demonstrate a fair amount of ignorance here. If you go back to your previous slide, you were linking with LV libs, correct?
Yes.
And then there's this magic that happened, and you started linking against LV lib or pack project libraries.
Yes.
Can you walk me through the workflow necessary to make that transition? In other words, I was linking against the VI, now I'm not linking against the VI. Did I have to do anything?
You have to build each of your library into a PPL.
And then?
And
Then
yeah.
you need to run the conversion tool.
So I run the conversion tool. Does that mean that all the VIs that used to call VIs, do I have to update the caller to now point to a PPL?
absolutely, yeah.
So is that manual or is that automated?
That's manual, and that's part of the pain.
So now, when we,
There's a manual.
There is a replace
Yeah,
with
there is
pack
a
library.
replace pack library
Yeah.
with, or replace with pack
Library.
project
Yeah, so you don't have to go to each caller and replace the VI. You can replace basically, you right click on the LabVIEW and replace with pack library.
is there the reverse of
And-
that?
No.
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 2019.
That's
Okay,
correct.
so the reason why that.
He's
that
gonna
gets
show
me-
that.
Okay, so the reason why that concerns me, so now I'm a developer, and I have my main VI, I called into a PPL, oh, there's a bug. Well, so do I have to go to the PPL source, re-export it, reinstall it, or is there a way that I can edit in place?
No.
No.
Okay.
And that's part also, I mean, for me, it's the beauty of the modularity. You have an issue in that PPL, that's its own product. You go in the source of that product, you fix the product, you run your test, you rebuild, you deploy. Alan?
Going to PPLs commits you to
That
a
really is
build
fun.
map and packages and making sure that your package is good to go before it goes out, and testing the package by itself, which is really, it's how a lot of.
You need to have a solid.
Which was why
process
you
in
gathered
place.
all your requirements in the first place and wrote your unit tests.
So I move forward. I have
Don't worry,
slides
you're a
that-
champion
No,
now.
all right, let it go,
Don't
let the
write
man go,
bugs.
let the man go.
I move forward. We have a lot
Man
of content to talk, so I advise those points.
We all happy to talk about this over beer later.
And there is another caveat.
Dimitri.
Matthias is gonna show that.
So
Go to that.
you can see here that basically each PPL is it's on file. Okay, so it's also easier to distribute and share these components because it's just a file. And if you deal with complex installers, etc., it will help you also. It's easier to distribute a single file, to install a single file than installing multiple files, etc. Additional benefits, so distribute and share your module as single files, and you can see that each PPL also have a file version. So when you get a bug, it's a lot easier to track down your bug to a particular version of your library. You can publish smaller updates. No need to redistribute the entire 40 meg application if you just have a bug in your report PPL. You rebuild the report PPL and do it later. Hello?
Have we, did I recall that we've graduated to the point where if Signal Analyzer 1.0 needs to be updated to 1.1 and the API hasn't changed, that I can just swap them on disk
Yes.
now? Okay.
Mostly.
Mostly, if the external API has not changed and if you have checked the adapt colors
Okay.
when you build the
There's an option for that.
Okay, and there's a few times where we've seen it not work and we've had to rebuild. I don't know exactly why.
It's tricky with tag definitions. If you update a tab definition, even if you don't change the public API, most likely you're going to need to rebuild also the colors. You can share your API while protecting your IP, okay? The source code has been removed. There is no way someone can go to Google and type how to crack LabVIEW password protection and figure out what's in your code. Okay?
Unless
Know
you-
that that's possible.
Unless you compile with debug.
Yes.
Yeah.
Absolutely. Same for an executable. If you compile with debug, you can debug and see it in the source. I'll talk about plugin architecture, which is a big benefit of PPLs. And I could spend 2 hours talking about plugin architecture, so I'll try to not do that.
What are you talking about?
So what's a plugin? It's a software component that adds specific feature to an existing application. Basically, when an application supports plugin, it enables customization. Third-party developers can extend your or an application. You can add features without modifying the main application. The main application only depends on the plugin interface, not on specific plugins. You reduce the size of the application, as we saw earlier. You can load plugins dynamically as you need them, so you have a better usage of the memory. And the installation of plugins can be completely independent of the installation of the main application. So let's work through the process of that. First, you start with your plugin interface. What is the plugin interface? It's a library, because you need a library to build a PPL. And then you have a class, which is the parent class for all your plugins. And you implement the dynamic dispatch methods that you will need for all your plugins. It's optional, but I like to build my plugin interface into a PPL, but anyway, it's going to be loaded with the main application, so you could keep it source.
If you don't do it as a plugin or PPL, you can get multiple copies in your runtime memory.
Yes.
Because then each plugin that you load that uses a shared library will load a copy of it.
That's a very good point. So Mark is saying that if you don't build it in the PPL, any plugin that is using the plugin interface will create its own copy of the plugin interface code. So
build it.
yeah, yes.
You also, and I've encountered this dealing with classes, if you, in one case you use a PPL and other cases don't, you run into namespace issues of successor is led to this, but the key extension at the end is noticed by LabVIEW when you're loading it. It goes, oh, you're not a member of this, you can't touch it.
Yes.
So you need that consistency across whichever you're doing.
Absolutely. Yeah. yeah. So I like really to build into PPL and put everything in the same folder. Define a plugins folder, and you're going to put your plugin interface and all your plugins in the same folder.
Where are your unit tests?
It's not a session on unit tests, it's a session on PPL. Definitely you should have unit tests and maybe other tests that will check, make sure before you build that you disable the debugging, maybe if you build the release, etc.
So you said you put all the plugins for this application in the same location?
Yes,
What if your plugins are designed to be used across applications?
I'll talk about that. Plugins, so again you create a separate project. Each plugin has to be considered as its own product. You create the library because you need it to be a PPL, and you have you create a child class, and it inherits from the plugin interface in the PPL. Okay, you see the extension P. So when you build your plugin, you set the class to inherit from the plugin interface class that is built already into a PPL, not the source. Okay. And then you implement your dynamic dispatch overrides for what you need in your plugin. And you build your PPL, place it in the same folder where you have your plugin interface and your other plugins. And you check exclude dependent pack libraries when you build in your build specifications. Those are separate, they are independent products. If you don't check that, since the plugin depends on the plugin interface, it's going to recopy the plugin interface PPL into the plugins directory, but you already built the plugin interface as an independent component. So always, I don't see any case really where you shouldn't exclude.
There is a current bug with that right now. It has to do with the level of depth between your source code and your destination of your PPLs. If those don't match, it changes paths on you, and your PPLs won't find anything, you know.
There is some workarounds to that. Yeah, there can be some cross-linking issue, and the PPL basically, the VI saved the relative path when you build into a PPL, and you could have some issue if you have large hierarchies. But I'll show how you can tweak that. So in the end, you end up with a plugin folder with your plugin interface and all your plugins. From your main application, you're going to want a VI to basically get the path where your plugins are. So usually you try to do that relatively to the application. But it could be something if you reuse your plugin into across multiple applications. I mentioned that again later. You should agree on a central location where you put all your plugins, and it's going to be always the same. See my company, my plugins, and you know it's there. And if your customer wants to put them elsewhere, it breaks, and it's responsibility. Then you want to list the plugins. So how to list the plugins? You list the folder where your plugins are for the extension LabVIEW, and we're just going to filter out the plugin interface. So I like to use statically the class. So if I change the name of my plugin interface, etc., I don't need to update that code. And I get the plugin interface LabVIEW, and I just filter it out. So in the end, I have my plugins 1, 2, 3 when I run this loop. In order to load the plugin, this is the whole magic of the plugin architecture. It's using the factory pattern. And basically, you're going to dynamically get the default value of your plugin class and cast it to the plugin interface class. So then you have your plugin interface class object on which you can call any dynamic dispatch method for your particular plugin. So this is really the magic of the plugin architecture. From your main application, we can see that we load the plugin, and then we can run our dynamic dispatch method on the plugin, regardless of which plugin is loaded. If we look at the project, the application only depends on the plugin interface, not on the plugins themselves. So I'll show you, oops, sorry. So let's run this application. I like execution, I list the plugins, I populate my ring, and then I run plugin 1. So I load my plugin, and you can see that at that point, my plugin 1 is now in memory in my project. And then I can use the dynamic dispatch on it. Any questions? So sometimes you want to unload. You can see that after I finished the execution, the plugin is still in memory. You would like maybe to unload that plugin from memory for many reasons. Let's say you want to update your applications without restarting an application. Sometimes you have some critical applications running. They don't have, they should never stop, but you need to update. So if I update my PPL on disk while it's in memory, LabVIEW doesn't see the change. It still is in memory. The only way that the class is able to leave memory, and I'm quoting Stephen Loftus-Mercer from R&D here, is when we detect that all the VIs using that class are idle and themselves leaving memory. So we usually think that it's easier to unload something than loading, but it might not be the case. Okay, it can be a disaster. So basically, we have to make the caller VI go idle and unload that. How to unload the framework? There are several ways to do that, but one way would be to use VI server to call the plugin code instead of calling the plugin code directly off the block diagram of your application. So we create a VI that we call run plugin VI, and we're going to run with VI server, open a reference to that VI, run the VI, and then in the end, when we are done with the execution of our plugin code, close the reference to the caller VI. And the run plugin VI is basically the code that loads and executes the functions on the plugin. So let's do that. I run my VI. You can see in the dependencies that I only have the plugin interface so far. I run my plugin 1. Now I open the reference, so the plugin 1 is in memory. Okay. As soon as, so I'm done executing, as soon as I'm closing the reference to the caller VI, the plugin left the memory. Okay. So if you want to learn more about this, there is a very good blog post from Russell Blake. So you search on Google refueling in flight, LabVIEW Craftsman, it's on LabVIEW Craftsman blog, and you have all the details on how to implement this. Again, if you have the bit.ly, you can download the slides and get the I like to use plugin architecture not only to load functional component plugins dynamically, but also to load UIs dynamically. Sometimes you have large application, but only, management will only use that part of the application. Test engineers will use maybe the bigger part, etc. So they don't need all the application in memory. So you can use plugin architecture to basically load dynamically your code in memory as you use it in the application. So you define an additional layer based on the UI, how you're going to navigate through the UI. So again, you create kind of a plugin architecture with a plugin interface, the UI LVLP. This is the only thing that will be loaded in memory when your application starts. So it's almost instantaneous. And then if you need to access the config, you're going to load the config and all the related functional plugins that it depends on. So I have large applications, I run them in memory, it's just a couple megs, and as I navigate, it goes in memory that way. So that can be really powerful. I'm sure you all have seen applications where you double click and you have to wait before something shows up. and it's not really looking good for your customer.
And you can plug in that UI
Yeah.
so that you can put this on different screens or even different devices.
It's all in your imagination. Yeah. Some recommendation, tips and tricks when using PPL. Each module library should have its own project, its own product. It should have its own source code control repository. I hope you all use SCC. If your modules are intended to be used within multiple applications, agree on a central target location where you build, and I am showing to Chris here. You agree on a central location. See my company, my PPLs, the version maybe because it can be version dependent. And you put all of them in there. So you know where to find them, okay? And you can use the custom configuration file for your application executable to tell explicitly my plugins are in this folder.
So does this in effect start to behave like a global assembly cache of sorts?
Sort of.
Sort of.
We actually use the public program data directory in Windows.
That's probably one of the good place. I like also to put in like C Studio Buds because it's when
It's a branding.
they see it's you. So VI search path and show load progress dialog equal false because you don't want to see when it's linking to the path. You don't want to see that loading dialog that you have in LabVIEW. Always exclude dependent pack libraries when building your PPL. They are separate products. No need to recopy something you already built and are developing independently. When you package your LabVIEW into a PPL, any dependency that is not in the runtime engine will be copied and packaged in the PPL. So basically anything that is not the LabVIEW primitive, even if it's in VILib, like the space constant. We heard at the LabVIEW champion contest that the space constant is a sub-VI, it's not a primitive. Every time you're going to build a PPL that is calling the space constant, it's going to package that VI into the PPL. So you can end up with a lot of times the main VI in each PPL, so it's not really efficient in terms of memory. So an example. Let's say you have multiple DQMH modules, and they are each packaged into a pack project library. We have these three classes that are dependencies of DQMH, and they reside in VILib. And every time I'm going to package my module into a PPL, those three classes are going to be packaged into the PPL. And I end up with many copies of the same class into my PPLs. So I have PPLs that are larger, more data on disk, and more data in memory when you load them, because you load multiple copies of the same thing. So the solution, you create a PPL with your dependencies. So I'll show the example for DQMH, a DQMH project. So first you create a library for your PPL DQMH. On disk, I'm going to move my, so you can slow down if you don't know this. So I move the classes into my library, I save all. So at that point, all my code now depends on the classes namespaced by the library. Now I go create a separate project, and this is that project that I will use to build my PPL DQMH library into actually a PPL. So I select my LabVIEW, I create my build specifications for pack project library. It's going fast, but you all know what to do there, okay? All right. I close that, and now I have my PPL. Now that's the interesting part, Chris. You go back into your main application, which depends on PPL DQMH LabVIEW. You right click and you do replace with pack library. You go find your PPL, and boom, now your colors depend on the PPL, not anymore on the LabVIEW.
Can you do that programmatically?
No.
With scripting, probably?
No, I asked that question,
Would it possible?
open eye, and they say no. There are ways to do it, but we don't advise doing it that way.
So you don't get so.
And this always
Who did you talk
works, this
to?
replacement. For you.
This replacement,
Yeah.
yes.
It doesn't work for me in some cases. You can share that over.
Okay. So I'd like to take the opportunity to just maybe have NI people sitting at the back of the room to introduce quickly themselves, just their position. And if you have more questions on this kind of tricky things, they will be there at the end of the presentation to answer. So Alejandro, yeah. So you have the best guys to answer all your questions.
That specific question, there is no public API for automating staff.
So I continue the video. You should not forget to go back to your DQMH LVLib and move back out your classes. So anything that is not built into a PPL is broken. You know, you want to keep your VI lib as it was before. Okay. So now if I go into my application, you can see that I'm not depending now on the LVLib, but on the PPL. This is DQMH built into a PPL. Other recommendations: conditional disable structure always execute runtime engine equal false, regardless of you call your PPL from an executable or from the LabVIEW development environment. Okay, so that's considered as a bug at NI, and there is a bug report created for that. But be aware of this; it doesn't work. So if you want to know whether your code is called from a PPL or not, you can use the pack library path, and you use this VI reference. And if the path is empty, basically you're not in a PPL. So there is a pack library palette that if you use PPLs, you should be aware of. There is just 3 VIs, but they do all what they need to do, all what you need. So the caveats now. You must rebuild your PPL for every LabVIEW version and OS, and this is solved now with backward compatibility. But otherwise, you need to have that process in place. And at Studio Buzz, we are building the tools to help you doing that seamlessly. It's not really to be a public product, but that's the intent. PPL expose your API to the LabVIEW developer. So, yeah, of course, if you take your PPL and you go into LabVIEW, you're going to see the VIs, and you bring the help, and you're going to see the inputs and outputs. So if you are really, really concerned about protecting your IP and nobody being able to understand how your application is built, that might not be a good option for you. So be aware of that. Only include related VIs into a PPL. When you open a VI in a PPL, all the VIs in the PPL are loaded in memory. So don't use PPLs as a store for all unrelated VIs. It's going to slow down your loading.
And you're going to want to be very careful about your package design.
Yes. So it helps in many ways in development.
Yeah, do it the solid way.
Exactly,
Yes.
do it the solid way. PPLs don't support MatScript nodes. Sorry if you use MatScript. You can leave the room. It's not for you. Replace with packed library is a one-way process only now, so it's coming in LabVIEW 2019. We should have the reverse way, which when you want to debug, sometimes you need to go back to source, and it's a pain. It's a pain. Other credits, I have many slides with credits. There is no built-in licensing options. So you can license libraries with dplat and other things, source libraries, but for the PPL, there is no built-in licensing options. And we will talk about that, but NXG should address that in the future. no easy way to build palettes for a PPL. Okay, even if you have your library containing a palette into and you build that embedded into a PPL, the palette in the PPL will still reference the VIs in the source library, which sucks. Okay. So I found out that the best way is to create your own palette generator tool for PPLs, and it's not a big deal. And if you don't want to do it, you just ask me, and I'll sell you the source code of what I've done, and you can modify it to your needs. And I put that as a post-build action for my PPL build specifications. And whenever I build my PPL, it creates the palette correctly, linking to the correct files. Yes, Alan?
Will quick drop find VIs and PPL, the PPLs in the project?
Sorry?
Will quick drop find?
Yes.
VIs? So, you're good.
Who needs pallets? That's what he's saying.
For discovery, sometimes you need to have palette, and if you sell a regular product, you know, people are
Customers.
accepting to see your
Darren would say well, you're fine.
Yeah. So
You can't hover over the help in a quick drop.
So just to be really precise, Quick Drop will find the public API of your PPL. Everything that is private is hidden.
It is private. And
Private,
it shouldn't be
yes.
found.
Yeah, exactly.
Exactly. The library name is part of the namespace, which is an issue because the same type def in source is a different data type when it's built into a PPL. And NXG will address that by just removing the file name from the namespace, from the fully qualified name of the PPL. PPLs cannot reference regular support files. You can still put HTML pictures in your library, but when you build them into a PPL, they show as missing files. PPLs cannot build if already in memory. So you cannot build with circular dependencies. And there are different views on that, but I believe you shouldn't have circular
But it's
dependencies.
the same with LabVIEW. You cannot have two VIs with the same name.
Yes,
Yeah.
exactly. So to summarize, you must have a solid build process in place to use PPL. And that's really what we are trying to do at StudioBoard, is really to give you the tools to make that seamlessly. So let's talk about this build process. If we look at the components hierarchy, you have component A, which depends on component B, and C depends on D. You need to build bottom up, okay? So you first build component D into a PPL. Then you go to component C, and you replace the dependency with the packed library. So now your component C depends on the PPL version of component D. And you do that bottom up. And in the end, you end up with component A, PPL, depending on all your PPL's version. If you look at the class hierarchy now, it's the opposite side. Okay, so we have animal and bird inherits from animal, and parrot and penguin inherit from birds. So you first need to build animal, and then you go to bird, and you change the inheritance of bird to inherit from the PPL version of animal, etc., etc. There is a tool, MGI Solution Explorer. It allows to basically build multiple build specifications in a specific order, so it can really reduce the pain. You define all the order, etc., and you can build all that in one click, and it also detects which library has changed and not, so it doesn't rebuild what is not needed.
Also, part of our build process to address Chris' concern is we generally build two versions of our PPL, one with debug, one without.
Yes.
So that in the runtime environment, we're pointing to the debuggable. You can't modify the code, but at least you can go in and interrogate, and then our release versions go against the release that have no.
And MGI Solution Explorer has directly the option in
Yeah.
the menu to build the debuggable version of the release
They
version.
have the same, yeah.
They have the same name, we just point to a different directory. So our program data, we have kind of a development and a release.
So what is NXG doing to avoid those caveats that we are going to discuss? In NXG, libraries have the jig component extensions. I heard that it might change in the future, so don't take that as cash. It's similar to the LabVIEW library, the LabVIEW plus the build specification. So the component, the LabVIEW NXG library knows how to build themselves and what's the output of the build. You can organize your source code using multiple namespaces into the same library, okay, which you cannot do in CurrentGen. So if we look in CurrentGen, we have my library.lblib with X and Y VI. X is public. And if you look at the fully qualified name, you can see that the fully qualified name of the VI contains the name of the library. Now if we look at LabVIEW NXG, we have my library.gcomp. We create a namespace A. The public VI is now named exported VI. And the library file name is not part anymore of the namespace. Okay? Only the namespace is in the fully qualified name. And for this will basically solve a lot of issues of cross-linking and swapping libraries in the future. So in NXG, we don't use the file name anymore. And this is true for classes as well. This is the vision, okay? All what I'm going to mention is not especially available right now, even in the 3.0 beta, so our folks at the end of at the back of the room are available to give you more precision about what is there, what is not there, etc. Yes, please.
So in your experience, have you tried migrating any LV-libs and PPLs into NXGen using the migration utility?
Yeah, just for the fun, yeah.
We have different definitions of fun.
Okay, that's just kind of ask.
Not to really use them, but to see how it behaves and start to be prepared.
What is your recommendation at this stage? So let me give you a scenario. Say that this is the true scenario. So I haven't done any investment in PPLs, and given the changes that are on the horizon, would you recommend waiting before refactoring into PPLs before going?
No, because it will be a lot easier if you do refactor in PPLs now, because it's really the same paradigm in NXG. Your G components are going to build into GLLs. It's pretty much, if you do that already in CurrentGen, it's going to work pretty much the same in NXG. So
Yes, but along the road, he will have all the pain that you listed.
yes, but if you want already to take advantage of the benefits of PPLs today, it already saves a little bit of work for the future.
So in your opinion, there's going to be pain either way. Is the pain lesser if I wait until I start in next year or starting now?
I would go now.
Yeah.
They're extremely useful.
And right now, you are familiar with the environment and everything else, so you would just be learning that. Where if you wait until you go to NXG, you're learning the environment and everything else plus this.
And
so
in
at least you will
NXG,
have
they
something.
expect you to work like that in NXG. It's going to work like that. So if you do it right now, the migration will be also less painful, I think, because it's using the same paradigm.
Also, you can try. Sorry, you can try one library at a time.
Yes, but for 1 year at least, you won't be able to convert back to the source, the code sites.
Yeah.
Right, so that means, okay, that's good. I'm trying to weigh out the advantages and disadvantages.
He was going to say something and I interrupted.
Can you elaborate on what you just said? Like, in NXG, it's going to work in this manner? Like, you're going to be forced into that? That's how it's going to be?
It's going to be the default behavior, and our guys will be able to elaborate on that if you want at the end of the presentation. But yeah, the default behavior would be that any library can be statically compiled into your application. So basically, you end up with a big application, everything statically linked. Or, which you should do, they're each going to build into a GLL.
So by default, each library is built into a GLL, right?
I think you can choose. Let's discuss that later.
Okay.
I don't have the answer. I'm not sure. So yeah, the vision is that GLL is equivalent to PPL. It's binary. It can be loaded at application runtime, so you reference statically and everything goes into the executable. Or after the application has started, you can load dynamically from disk your GLLs. It will be platform specific. Again, it's compiled code, so you have to recompile for RT and Linux. And, contains metadata, author, company, version. Maybe there will be some more flexibility to add custom metadata. Again,
Lock
the doors.
In next gen.
wouldn't be unloadable, like when I showed unload the framework.
You need to do the same trick.
I don't know, probably.
What was the question?
Would the GLLs be unloadable in an easier way?
So
Yeah.
question for those guys at the end.
That's the idea.
Yes?
That's the idea.
That's the idea. So there are live goals, live goals.
Eventually.
Hello.
So you will be able to build libraries independently or as part of the calling application. So directly in your project, if you build an application in NXG, it will automatically build, if needed, all the libraries called by the application. You work everything in the project. No need to keep track of the build hierarchy and perform the manual bottom-up process that I described. NXG will be able to consume a source or binary form of the library. No need to separate into different projects, as I said. And it will be a lot faster to build because, and it's true for any build in NXG, not only GLLs, but executables. It's pretty much copy from the cache to the target build directory. Swapping libraries, that's a very, very big improvement. You can replace in NXG, you will be able to replace in NXG a library by its complement form, so binary to source, source to binary, by its debuggable binary form, different version of the same library, or a different library which has the same public interface. Okay, so a lot of flexibility with that. So the library file name is not part of the namespace anymore, which brings a lot more flexibility. You can choose to use the source or the binary form of a library. Names are now resolved by the project instead of by a relative path, so it will be almost impossible to have cross-linking with that. VIs will not remember anymore the relative path. It will use the project will use the namespaces to resolve where are the path. Multiple hierarchical namespace in one library, and multiple different libraries can contribute to the same namespace. So I didn't find any precise use case example, but I think that it can be really interesting. So no need to revalidate and retest all the libraries every time you build your application. Other goals, protection of the libraries in NXG. Whether it's a GComp or a GLL, it's just a library, so you will be able to license the same source or build version of the library. Who can view the code, who can compile against it, who can use it at runtime, so these are all goals. It's not right now in the product. Support multiple engine versions as long, it might not be as easy as at the beginning because LabVIEW will evolve quickly, but between stable keybox of LabVIEW and NXG, it's going to work like that. Okay. So again, if you didn't take the picture of the link, you can download the benchmarking code and the slides. There are more information on ni.com/tech-preview regarding NXG. Sequence for pictures. If you want to go to Cambridge in beginning of September, it would be great. We have a new conference in there, and I will continue the discussion over there, more specifically about using PPLs for packaging and deployment. Okay, so more the deployment side of it. Okay, so more coming soon on PPLs.
Get your tickets if you want.
Please take the survey. We appreciate the feedback, whether it's constructive or positive. And if you have questions, we are running out of time, but I'm happy to take them here until we get it out. And again, if you have more technical questions about NXG, we have member of RMTs.